Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about uniqueness and existence of the first order differential equation. I will cover all those questions from the CSIR NET examination 11 to 2023. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the playlist of the CSIR UGC gate. Here you can see the PY questions related to the different topic wise as well as the subject wise, such as the Laplace equation, gate and the CSIR NET questions, multivariate distribution, function of the several variables, complex analysis, sequence and series, and many more. Is complete list is available in this playlist. I am sure that if you watch the complete lectures, you will solve or you will qualify the NET and the gate examinations as well as the IIT JAM in a very simple and efficient manner. So what is the objective is we will cover all those questions which covers the first order differential equation. So before I start with the PY questions directly, I will, as usual, I will give you the several shortcut tricks which is available only at my YouTube channel Dr. Harish Garg. So whenever you have a differential equation, try to always find whether there is the existence of the solution or not. Everything which is dependent on this function f. What is the nature of this function f? That will define whether you will get a unique solution or here. The main objective of this is you have to check whether the unique solution existence, whether the no solution, or whether the infinite solution. And then we will see under what conditions, what are the conditions for the first order differential equation so that this will happen here. I am sure that if you watch this lecture completely, you can solve each questions within a 10-second related to this topic of existence and uniqueness. So first condition, firstly you have to prove that this function is my continuous. If you prove that this function is my continuous, then that is sure that at least one solution will existence. It means this no solution will condition rule out. For example, if you have the function of x square plus y square, so clearly say this is my polynomial. So what is this? It means it has it's a continuous function. So it means definitely at least one solution will be there. Now the question arises is if one solution will be here, then when it will be the unique solution and when it will be the infinitely many solution. So that will be my second condition. If you prove that this function f satisfies the ellipsis condition, what is the meaning of that? The partial derivative of this function f with respect to y is my bounded. If you prove that the partial derivative of f with respect to y is my bounded, it means is f satisfy the ellipsis condition. Or you can say the function f and the partial derivative of f both are my continuous function. If you prove that the both are my continuous function, then there exists a unique solution. Then there exists a unique solution. But remember that unique solution is always existing in the interval which contain x naught. If I say my interval is here, then this unique solution is existence. Say my interval says 3, 4, say minus 4, minus 1. So clearly says this is my x naught. X naught is lies in this case, not in this, not in this case. So unique solution is occurring in this interval, not in this and not in this. So that's the meaning of the unique in some interval which contains my x naught. Next remark, if you on the other hand, if you prove that this solution is my unbounded, that means if you take the partial derivative, then there are the two cases. The first case is either you get a no solution or you will get as a infinitely many solution. So if you want to prove that there is a no solution, you have to prove the partial derivative is my unbounded. It means Lipschitz condition not satisfied. Then either the no solution or infinitely many solution. If you want to find the region around this x naught and y naught, we can define as a rectangular region, and the interval of the existence is my x is less than h, where h is a is my upper bound of the domain, b is my here, m is my maximum value of this function fx. If my function is say sin x, then we clearly say what is the maximum value of this fx. It is always less than 1. So this is my m. M is the maximum value of this. If it is a x square plus y square, then we can find the maximum value of this x square plus y square is, it is a less than of mod x square plus mod y square. If you prove that this function f is my bounded and continuously differentiable, means Lipschitz condition satisfied, then there is no need to find such case. Then in that case the interval is my less than infinity. That infinity means what does it mean? Minus infinity to plus infinity. That means it's a real line. The last most important concept is, it's a very important concept for you. Whenever you have the partial differential equation, then you will check when the no solution exists, when the unique solution exists, and when the infinitely many solution exists. That will depend upon this A and the C. Remember, it should be the first order differential equation, and the value of this alpha should be lies between 0 and 1, like y dash is root of y. So clearly say this is my half is lies between 0 and 1. Then there are the two cases whether the A is my positive or negative. If A is my positive, then you will get a unique solution if this initial condition is my positive value. If this initial condition is my 0, then you will get as a infinitely many solution. On the other hand, if your A is negative and C is my 0, then you will get as a unique solution. Remember, here B is my real number. You may have this case, you may have this case, because this is a real number, this is my real. So based on these 3 or 4 shortcut tricks, I can solve all those PY questions in a very simple 10-second minute. I'm sure if you watch my complete lecture of this, you will solve each question in a 10 seconds. So before I start with the PY question, you can simply scan and join my WhatsApp group if you want to join with me and discuss the various shortcut tricks. So let's start with this one. P is a polynomial of degree n where n is my greater than equal to 2. So I can assume n is my 2. As I always told you, whenever there is an unknown parameter, you can think about this. So P is a polynomial of degree 2. So I can choose as a x square. That's very simple. So this value, what is the meaning of that? This value is nothing but my u square. So can you find the solution of this? I can integrate them. This is 1. This is with respect to t. So it is minus 1 over u t plus c. Now u of 0 is my 1. So what is my c? C is my minus 1 because 0 and 1. So therefore minus 1 over u is t minus 1. So u will be 1 over 1 minus t. Fine. Now clearly say this solution exists for all the t, but it is not equal to 1. So look at that, a unique solution. But this is the one counter example I have taken. We can't take the option. We always discard the option. N is my 2 number of that distinct solution, but we get a unique solution. Fine. So this option is cancelled out. No solution in the interval containing t is equal to 0, but we can't discard them. A unique solution, we can't discard them. Now look at the one more. If I consider the polynomial is simply because it's not existing at the 1, so I can simply say x minus 1 whole square. Then u dash will be my u minus 1 whole square. If I integrate them, you will get this solution. Fine. Then u of 0 is 1. What is the value of the c? This is my 0. This is my 1. So c will be infinity. So what does it mean? Do you get any solution? Do you get a unique solution? There is no unique solution. So I can discard this option. Again, a unique solution. There is no unique solution. So the only left option is my C is the right answer. Remember, when you consider as a particular example, your target is to discard the option. Now since we already discard the 3 options, the only left option is my C is the right answer. Look at this another one. Consider the equation this, where f is my bounded and continuous function. Can you think about any of the function which is bounded and continuous and as simple as, so you can simply take it as a constant function. Fine. And in the constant function, the easiest one will be my 0. So what is the function? Y dash is, this value is my 0. it is my y. Fine. So can you find the solution of this? This is nothing but y is equal to c e raised to power x. You all know I can simply take m minus 1 is 0. So m is 1, so c e raised to power x. So but here is a function of t. So I can simply take e raised to power t. Then y of 0 is 1, so it means c is equal to 1. So my solution is y is equal to e raised to power t. So it admits a unique solution, yes, fine, but we can't take the option because we've taken as one particular example. Limit of the y when t approaches infinity. So what is the value of this? It's a infinity, but he said exist and finite, but it's a infinite. So this option is cancelled out. This equation admits the two linearly independent, but we get as a only the one solution. Fine. So this option is also cancelled out. This solution admit a bounded solution. So we can check about what is the mode of y is e raised to power t, and clearly say e raised to power t is my unbounded function. Remember, e raised to power x is my unbounded, but e raised to power z is my bounded, where z is my complex number. So but here t is my real number, so it is a unbounded. So it said a bounded. This option is also cancelled. The only left option is my D is the correct answer. You can see it's a unique solution, fine, and the limit is my infinity. So since all the options are discarded, that's why we can take about this option. Look at this another one. Consider the initial value problem where f is my continuous function. Where f is continuous function. So you can choose any of the continuous function. I can choose as a 1, or 0 is also the continuous function. So if f of t is my 0, y dash is my 0. So y dash 0 means that is my constant. Fine. So can you find this constant c value? Because y of 0 is my 1. So c is my, what is the y of 0 is my 1. So c will be my 1. So y is equal to 1 is my solution. So the infinitely many solution for some f, but I consider one particular f. It may happen for the sum. Unique solution, that's true, but we can't take the option because this is a one counter example. No solution for some f. If it is said for all f, then we can discard the option. But it may happen that a solution is there, so we can't discard any of the option. So what is the meaning of that? We can use in journal. So this is my f of t. Now if I integrate them, it is my log of y is integration of f of t. So what is the y is? Y is equal to c e raised to power integration of f of t dt. Now f is my continuous function, it is given. So it means the integration of f of t is my existence. So let's say this is my L. So what is the meaning? C e raised to power L. Now what is the y of 0 is 1. So 1 is c e raised to power f of 0 dt. So I consider this is my L naught. Fine. So what is the value of the c is 1 over e raised to power L naught. So what is the value of the y? Y is e L minus L naught. L is my existence, L naught is my existence, so this is my existence. Now you can see infinite solution for some f, but it is existence for all f. So infinite many cancel. No solution, cancel. It is existence for all f and for all t is in R. But you can see not on the R, but this option is also cancelled. The right option is the left behind is B is the right answer. Look at this one. Y is my differentiable function such that here f is my ellipsis continuous. Fine. What is the meaning of that? This partial derivative is my bounded. Fine. So what this means, f is my continuously differentiable function, and you can see that y is my differentiable such that this condition hold. So what is the given to you? Y is my differentiable and y of 0, y of 1 is my 0. What does it means? Y of x is my 0 for all x. Clear? Now look at the option. Y is my 0 if and only if x is either 0 or 1, but it is for all x. this option is cancelled. Y is my bounded, so mod of y is 0, which is less than of some k, so it is a bounded. Fine. Y is an increasing function, but y is neither the increasing nor decreasing. Cancel out. Dy by dx. So what is the dy over dx? It is my f or 0. Fine. So if f is 0, so this is 0. So clearly say this is my bounded function. So this option is also cancelled. Moreover, dy over dx is my f, and f is my ellipsis continuous, so it means this is my bounded. So del f by. So anyhow dy over dx is my 0. 0 is the bounded function. So the right option is my B is the right answer. Look at this another one. Check whether the initial condition is a unique solution or not. So clearly says what is my f. So when it will be the unique solution? If f and del f over del y both are my continuous. So clearly says this is my polynomial. If I find that del f by del y is a 2y, it is also the polynomial function. Both polynomial are always continuous. So yes, it implies it exists a unique solution. So what is the condition for the uniqueness? So you can see there are the two methods. Firstly, I can solve this equation easily. So what is that? It is a minus 1 over y is x plus c. Initial condition is here. So c will be my minus 1. So minus 1 over y, x minus 1. So y is my 1 over. So what does it mean? It exists for all x but not equal to 1. Fine. So look at that. X is equal to 1, existence in this. So it means solution does not exist. X is equal to 1, existence in this. Solution does not exist. 1 also existence in this. Solution does not exist. Only left behind is my B is the right answer. Clear? There is one more method. So what is that method? Whenever you want to find the interval, you always start from here. What is the initial condition is? 0. So x minus 0 is less than a. Y is my 1. So y minus 1 is less than b, where h is minimum of a, b over m. I can find the value of the m. This is maximum of fx. Fx is y square. So can you find the value of the maximum value of the y from here? It is 1 plus b. So it is 1 plus b of whole square. So what is the meaning of that? Minimum of a, b over 1 plus b square. Now there is no need to solve it. We can check about the options. Because this is a minimum, it means what is the a? Upper limit of the a is infinity. So minimum is either one of them. So clearly say this number is always less than 1. Can this number is always less than 2? No. This number is always less than 1. So it means this option is cancelled. This number is less than 1. So this option is cancelled. This option cancelled. Only option is my. So what is the meaning of that? H is always less than 1. So if I substitute here, mod of x is less than 1. So what does it mean? Minus infinity, x less than 1 is my answer of this problem. Look at this problem. Now y dash 2 y raised to power half, y of 0 is my a. Now very simple. You in this case, are they ask you find the solution? No, they are simply ask unique, no, infinite, unique. So what is the shortcut tricks for you? Always apply this trick. Where you always apply this trick. Look at that. Half alpha lies between 0 1, satisfied. This is my belongs to the real, satisfied. Fine. So check whether a is positive or a is negative. A is my 2 greater than 0, satisfied. Now if c is 0, infinite many solution. C greater than 0, unique solution. So a unique solution if a less than 0. No solution, cancel. Infinite many solution if a is equal to 0. You can see infinite many solution if a is equal to 0. Right answer. Unique solution when if it's strictly greater than 0. but he says greater than or equal to 0. So that option is cancelled. Right option is only C is the right answer. You can see nothing is to solve. You can simply look at the answers based on this shortcut tricks. You can solve within a 10 seconds. I'm pretty sure if you watch this complete lecture, you can solve each question within a 10-second maximum time period. Okay, look at this one. Again, they are not talking about the solution. They are checked about whether it's unique or not. What is that? It's a 60 y raised to power 2 over 5. Y of 0 is my 0. So clearly says this number is lies between 0 and 1. This number is lies in the real. This number is my greater than 0, and this is also 0. So what is that? It means A is my positive. Whenever it's a 0, infinitely many solution. Fine. No solution cancel. 2 solution cancel. Unique solution cancel. Right option is my D. How many seconds you are needed to solve it? Maximum of the 10 seconds. Look at this problem. What is given to you? U dash is 3 u raised to power 2 over 3, and u of 0 is my 0. Again you can see 2 over 3 belongs to my 0 comma 1. This is my real number. 3 is my greater than 0 and it's my 0. It means it has infinitely many solutions. Fine. Now look at that, whether which of the following satisfied. We will check out firstly this, whether this satisfied. If it's a t cube, what is the derivative is 3t square. If I substitute here, it's a t cube of 2 over 3. So which satisfied. Fine. So it means this is my correct option. U of t 0, again clearly say u of t 0 is clearly satisfied. 0 is equal to 0 is also satisfied. Now if you look about that, again it's a t cube. So look at that. What is that? They are shifting the origin only. They are shifting the origin on the t-axis. So look at that. If your solution is my here, you can shift the origin on 1 unit. So what is that? It's a t minus 1 cube. Fine. So this option is also correct. It is shifted by 3 units. It is shifted by 3 units. So it is also the correct option. All are my correct answers. Look at this another one. U dash is 4 times u of 3 by 4 and u of 0 is my 0. Again this number is 0 and 1. This number is my positive. This number is my 0. So it has infinitely many solutions. Fine. So once it has infinitely many solutions, we will check about t4. What is the derivative of this? 4t cube. So what is that? It's a t raised to power 4 raised to power 3 by 4. So clearly say it's satisfied. 0 is also satisfied. Fine. Again this is nothing but my shifting the origin by the 1 unit. So it's a t minus 1 of 4. It is shifted by the 10 units. It's a t minus 10 and it's a 0. So all are my again correct answers. Remember, if instead of this 0, if he said say 2, then it is not the solution, but it's a 0. That's why it's a shifting the origin. Okay, sir. Recent 2020. Y dash is y 5k over 5k plus 2. Initial condition is y naught is 0. And again they are not talking about what is the solution. They are talking about unique solution, 2 solution, infinite many solution, or no solution. What is the condition for that? You have to check of this case. So clearly say whatever the value of the k, whatever the k is in my real, this number is always less than 1. Fine. And since k is my positive integer, so this number is always 0. So that means this number is my greater than 0, less than 1. That means it lies between 0 and 1. This number is again a real number and it's a 0. Once this is a 0, what does it mean? It has infinitely many solution provided this is my positive, and clearly say this is my plus 1 is a positive. It has infinitely many solution. No unique solution, no more than one solution. Right answer is my C is the right answer. Okay, now you can see this is June 2023. The first problem, x dash. I can written this as a half. X of 0 is 0 and y dash, sorry, it's a y dash is minus y of half, y0 is my 0. So clearly say this is alpha slice between 0 and 1. It is my 0, coefficient is my positive. It has infinitely many solutions. It has infinitely many solutions. Here a is my less than 0 and it is a 0, so it has a unique solution. If it is a positive, then infinitely. If it is a negative, then unique solution. So it has a unique solution. So P has a unique solution, cancel. Q has a unique solution, correct option. P has infinitely many solution, correct. Q has infinitely many solution, cancel. Right options are B and C are the right answer. Look at that, how many seconds you are needed to solve the problem? Just 10 seconds. Keep watching that. You will learn many shortcut tricks at the end of this video too. Now again it's a September 2022. Again you can see first problem is my here where y0 is 0. What does it mean? Now you can see it's a 0. It has a infinitely many solution. Fine. This is my problem 1. What is my problem 2? Y dash is minus y half and y of 0 is my 0. Because it's a negative and this is the 0, it has a unique solution. So first has a infinitely many solutions. The first has uniquely solvable, cancel. Second is a uniquely solvable, fine. First has a multiple solution, fine. Second has a multiple solution, cancel. So B and C are my correct options. Remember, whenever there is a positive and 0, infinite many solution. But if I say this is my 3, which is a greater than 0, then you will get as a unique solution. But here is a 0 is my solution. Now you can see about the next question, the initial value problem. Y dash is x, y of 1 by 3, y of 0 is my 0. Again you can see this number is lies between 0 and 1 and it's a 0. It will give you the infinite solution only when this number is my positive. What is the domain of the x? Domain of the x is my real number. So it can be positive, it can be negative. It means if this is a pi positive, then you will get as an infinite solution. If this is my negative, because of this 0, you will get as a unique solution. It means no solution will not be achievable. So it means there exists a no solution. This option is cancelled. Fine. Because either the infinite solution or unique solution you can easily obtain, but no solution cannot be attained. So this option is cancelled. Moreover, one solution is already given to you. So that means no solution does not exist. Now, when it will give you the unique solution, as I mentioned in the earlier tips, if you prove that this function is my continuous, fine, or if you prove that this is my bounded. So what is that? F is my this. What is the partial derivative of f with respect to y? 1 over 3 x y of minus 2 by 3. So I can say this is 2 by 3. So clearly say this does not exist when around y is equal to 0. Check whether y is equal to 0 is a part of the, yes, it's a part of the real line. It's a part of the domain. So what does it mean? Lipschitz condition does not satisfied. Fine. So what does it mean? Now if I write for here, what does it mean? Lipschitz condition not satisfied. So what is the meaning of that? If Lipschitz condition not satisfied, then either the no solution or infinitely many solutions. So unique solution not existence. But we already see that the no solution will not be happen because this is alpha, either the positive or negative solution. So this option is also cancelled. There exists more than one solution. That means infinitely many solutions. The function does not satisfy the Lipschitz condition with respect to y in the neighborhood of y is equal to 0. Yes, this solution does not exist only around y is equal to 0. So that means the right options are A and D are my correct options. Look at this one, June 2023. Again, what is that? U dash is t square of 1 over 5 and u of 0 is my 0. Clearly say this number is my 1 over 5 lies between 0 and 1. This is my 0. So either this will give the infinite solution or will give the unique solution depending this number coefficient of this is my positive or negative. So clearly says if t is in my real number, t square is always greater than 0. That's true. It's a greater than or equal to 0, but it can never be less than 0. But if can never be less than 0, it means it can never give you unique solution. Fine. So we can discard the no unique solution. Is there any solution? No. Now look at the first condition. It does not satisfy the ellipsis condition with respect to u. So we can check about here. So 1 over 5 t square 4 over 5. So clearly says it does not exist. What is that? It does not exist around u is equal to 0. So what does that means? Around u is, he said does not exist. So this option is correct option. Look at this one. He satisfies the ellipsis condition with respect to u around u is equal to 0. This option is cancelled. If this problem said around u is equal to 3, then this is the correct option. Now if the ellipsis condition does not satisfy, then you have the two cases, either the no solution or infinitely many solution. No solution or more than one solution. But clearly sees from this differential equation we will get either infinitely many solution or unique solution. So no solution will not exist. And so no solution will not exist. It means the only case is infinitely many solution is the existence of this problem. Moreover, you can see one solution is already existence. This is my one solution. So the no solution is also cancelled. But always remember, when the ellipsis condition does not satisfy, you have the two cases, no solution or infinite many solution. But from the first case we see either this problem has infinitely many solution or unique solution. So no solution does not exist, but he said no solution. That option is cancelled. Okay, look at this another one. Again, this is the first order differential equation. Again, they are not calculating the solution. Unique solution, no solution, and here. So this is my f of xy. Fine. Now we can check about this ellipsis condition. What is that? Lambda cos x plus y. What is that? It is less than of this number. It means partial derivative, this is my here. That means this is my condition for the ellipsis condition. Now if you prove that this function is my bounded, then you will get as a unique solution. When it will be bounded? When this number should be less than of something. And you can see if this is my less than 1, it means ellipsis condition satisfied. If ellipsis condition satisfied, what does it means? You will get only as a unique solution. And also this function is my continuous, because sine is a trigonometric function, is a continuous function. Lambda is any real number. So you can get a solution, that means a unique solution. There is a no solution. When it will be the no solution? Only when ellipsis condition not satisfied. So ellipsis condition is, this is my lambda cos of x plus y. So what does it mean? It exists for all y, but he said in the neighborhood of 0, but it existence for all y, it means this solution is cancelled. A solution in the neighborhood of 0, yes, there exists a solution of this because it's a continuous function. A solution in the R only if lambda is greater than 1. What does it means? If I already proved, if this is my greater than 1, so what is the upper limit of this? It means it may existence to the infinity. So if this is infinity, it means this is my unbounded. Once this is unbounded, what does it mean? Ellipsis condition not satisfied. If it is not satisfied, you will get either as a no solution or infinite many solution. But look at that. He said a solution. That means he said a unique solution. But we get either the no solution or infinite many solution. So this option is also cancelled. right option is my B and C are the correct answer. Look at this another one. The initial value problem, the largest interval for the existence of this. So they are talking about the interval. Okay, f is my y square plus cos square x. Initial condition is my here. So x minus 0 is less than a, y minus 0 is less than b. My solution will be existence around h, where h is minimum of a, b over m. So can you find the maximum value of this? Maximum value of this is y square plus cos square x. It is less than of, what is the maximum value of the y from here? Is a b. Cos square maximum value is my 1. So I can substitute here minimum of a, b over 1 plus b square. Fine. Now how you can find them? Either the a or b. What is the minimum value of this? If I take g is my b over 1 plus b square, how you find the minimum value? Derivative should be 0. So 1 over b square minus b 2b square over 1 plus b whole square. Fine. Or you can take it as a u over b. So I can take the LCM, this minus this as a 0. So from here 1 minus b square is 0. So b is my plus minus 1, but we always consider as a positive value because y is my upper bound. So b is equal to 1. If I substitute here the minimum of a 1 over 2. So what does it mean? What is the minimum of this? Less than or equal to half. So h is my less than equal to half. If I substitute here, upper value will be my half. So that means upper value will be half. This 1 by 4 is outside. Upper value is my half. Largest interval is my this. Okay, consider the function here where f is my any function. It is not given whether it's a bounded, continuous or here. Which of the following statement is my correct option? Okay, y dash is my function of t. Y of 0 is my a. Fine. There exists a continuous function f. So if I assume f is my continuous function, this function is my continuous, such that our function does not have a solution. That's strong. As I mentioned in my first tip, if f is continuous, it means there exists at least one solution by using the existence theorem. Fine. But he said does not have a solution. This option is cancelled out. The problem has a unique solution. When this problem has a unique solution, when f is continuous and f satisfied Lipschitz condition, then you can get a unique solution. The problem has a unique solution for every a when f is Lipschitz continuous. Yes, true. Whenever f is Lipschitz continuous, it means you will get as a unique solution. That option is correct option. If f is twice differentiable and continuous, so it's a C2 function, the maximum interval of the existence, the maximum interval of the existence is my r. That is a wrong option. Do you remember that my earlier tips? If f is a twice differentiable function plus f is my bounded, then only the maximum interval is my r. Here bounded is missing. The maximum interval for the function is r when f is bounded and continuously differentiable. That's a correct option. So the B and D are my correct option. So you can see I already gave you the smallest tips in my earlier study. So that's the right option of second and the fourth are the right answer. Okay, look at this one. Consider the ordinary differential equation. Y dash is f y of x, where f is my even function and y is my odd function. Think about any of the odd function. The smallest one is x. Think about any of the even function. What is the even function? X square. Fine. But can you think about any of the easier one? It's an even function. Fine, because f of x is f of minus x. Now look at the first option. y of this, so what is that? Y of minus x, y of minus x is minus x, so it is my x. Is this the solution of this problem? So you can check about that. Okay, firstly, what is the function is? Y dash of x is, what is the f is? What is the y of x is my f, so it is my 1. So my differential equation becomes my y dash of x is 1. So is it satisfied? Yes, it's satisfied. Look at this one. What is the y of minus x? Minus x. Is it satisfied for this problem? Minus 1 is equal to 1. This option cancel. Minus fx. Again minus x, not satisfied. Yx is x. Y of minus x. Minus x. It means minus x square. Is it satisfied? 2x is equal to 1. Not satisfied. So this option is cancelled. Only A option is the correct option. You can see, always think about a very simple manner. You can think about any of the functions. So the only right option is A is my correct answer. Stay tuned with this video. You will learn many shortcut tricks in this next part also. Okay, if the solution is existence in the interval here, then the maximum interval for this interval is this, then which of the following statements are my correct? Okay, fine. You have to find the intervals. It means the initial solution is my here. X minus 0 is less than A. Y minus 2 is less than B. Fine. So your target is to find the value of the H, which gives you the minimum of A, B over M. Fine. Now you can see, what is the M? Maximum value of the X square plus Y square. What is the maximum value of the X? It is not given. Oh, maximum value of the X from here, it's A. It is less than or equal to A square. What is the value of the Y from here? 2 plus B. So 2 plus B whole square. So I can substitute here minimum of A, B will be my B, and it is A square plus 2 plus B whole square. Fine. Then look at the option. It's the L node. It's a greater than 1, less than 1. What is the minimum of this? There is no upper bound, so it should be infinite. Fine. What is the maximum value you can see about this problem? So clearly says this number is always less than or equal to 1. Fine. So whenever this number is less than or equal to 1, A has no upper limit. So what does it mean? The minimum should be less than or equal to 1. So that means L node is my can't never be greater than 1, can never be strictly less than 1, because it may be equality 1 as well. So first and the last options cancel. Fine. Now we can think about the second part. Again, for this case, we can found for this one, I can write x minus 0 is less than A and z minus 1 is less than B, and in this case H will be my minimum of A, B over M. So for that case I can found the M is maximum of Z square. So what is that? Z is 1 plus B whole square. Fine. So what is that? Is a minimum of A, B over 1 plus B square. So clearly say, what is the maximum value of this? Can you find the maximum value of this? Now you have the two options, whether it's a less than 1. Again, there is no upper bound of the A. Fine. A has an infinite value. Can this number, it can never be, it is less than 2, fine, but the largest number is, this number is always less than or equal to 1. Fine. This number is definitely be less than of the 1. So it means this option is cancel out, because he said the upper limit is my 2, but this is not the 2. Or you can find, if you consider the G is my B over 1 plus B square, then you can find the G dash is 0. You can find the value of the B as a 1. Fine. So what is the value of the G is 1 over 4. So it means minimum of A 1 over 4. It should be less than or equal to 1 over 4. So that value should be less than or equal to 1 over 4. But it's an open interval. So I can say this number is 1 over 4 lies here. So C option cancel. Only option left is my B is the upper. So that's the right answer. Both way you can solve in here. There is one more method that's directly come right now in my mind for this case, because this problem can be easily solvable. You can see I can write this function here. Fine. Now if I integrate them, it is my minus 1 over z is x plus c. Z0 is my, so c will be my minus 1. So therefore this is my x minus 1. So z will be 1 minus x. So clearly say the solution exists for all those values of the z and x which is not equal to 1. So that means this is my open interval of the 1. But in this case, if I say L1 is my 2, then interval will be my here. So 1 is belongs to this. So that's why this option is cancelled. So the only option is my B is the correct option. Okay, look at this another one. What is given to you? F. What is the meaning of the C1? It's a continuously differentiable function. Fine. So that means, what does it mean? F satisfied my Lipschitz condition. If f is a continuous differentiable function, f is bounded as well. Then x dash is my, this is given to you. Now, how you can think about this function? How you can solve this function? F has a unique solution, no solution, infinitely many solution. X dash is f of x comma t. X of 0 is my 0. Okay. Now, how you can say, what does it mean? If it's f satisfied my Lipschitz condition, what does it mean? It means it has unique solution always. Fine. So this P has a unique solution. Infinite solution will not be possible. Infinite solution only possible when Lipschitz condition not satisfied. P has a solution defined for all t. That's obvious true, because f is a differentiable, continuous and differentiable and satisfied Lipschitz condition. The solution of the P are my Lipschitz. That's a, oh no, this is solution. Solution means x. It means, okay, solution is my x. When it will be the Lipschitz? If you prove that its derivative should be bounded. This is the target. Okay, if P satisfy the Lipschitz problem, fine. So what is the x dash? X dash is my f. Fine. So if I prove that x dash is my f, what is my f? F is my bounded. So it means it should be less than of the k. What does it mean? X dash is less than k. That means x is satisfied Lipschitz condition. So what is the x? X is the solution of this problem. So solution is satisfied. Which of the following statements are my correct? A, B and D are my correct option. You can see it's a June 2020. How many seconds you are needed to solve the problem? Just look about these various simple shortcut tricks. Okay, look at this another one. F is my given to be here the largest value of this. The largest value of this. X dash is f of x of t. Initial condition is given to you. What is my f? It is not given, but it is given as a here. So I need a largest value, so I can choose this function as 4 times of the x. Fine. So what is the meaning of that? It's a 4x. Initial condition is x naught is 3. Now can you solve this problem? It's very simple. If I simply take m minus 4 is 0, or you can simply take as my here, if you integrate them, log of x is my 4t, x will be my e raised to power 4t into constant I see as a c. x0 is my c, x0 is my 3, so 3 is equal to c e raised to power 0, c is my 3, so solution will be my 3 e raised to power 4t. Now your target is to find the largest value at the 1. So what is the value of the 1 is 3 e raised to power 4 is my 3 e raised to power 4 is my right answer of the problem. Look at the next question. f is given to be here, initial condition y0, unique solution, bounded and safe. Again, x minus 0 is less than of a, y minus 1 is less than b. So my target is to find the minimum of a comma b over m. What is my m? Maximum of this. Fine. So it is less than of a has a maximum value a square, b has a maximum value 1 plus b square. But you can see x has a maximum value 1. So basically a is my 1. So I can say it's a 1 plus b square. So what is my h? H is minimum of a comma b 1 plus whole square. Fine. Now can you find the maximum value of this? How you can find the maximum value of this function? So clearly say, if I take g is my there is no need, I think this number we all know this number is definitely less than or equal to 1. So that means h is less than or equal to 1. So my solution is x dash should be less than or equal to 1. Fine. And the lower limit is my 0. So the interval will be less than, this is my maximum interval. Fine. Maximum interval of existence. Now the unique solution existence. So if you take the subset of this, that is my uniqueness solution. So we have to check whether the pi by 4, this over 4 is a 0.78, which is a subset of this one. So yes, there exists a uniqueness of the solution. Now once it's a uniqueness, it means the ellipsis condition and it's a bounded as well. Every solution in this case is my bounded. There exists a singularity at the some point in the closed interval this, and it's unbounded. Okay, once you prove is a singularity, it definitely becomes the unbounded. How you can prove the singularity? What is the meaning of the singularity? I get a solution as a y in terms of the x. If you prove that, it will go to the infinity for some value of the x, then it means it is a singularity. Fine. It's a very simple. If I simply take dy over dx, if I choose any number in this interval, I can choose, I have to integrate them also. So if I choose x is my 1, then it will be easy for me. You can integrate them because it's a tan inverse. So if I integrate them, dy over 1 plus y square is dx. So that means tan inverse y is x plus c. So y will be my tan of x plus c, and y of 0 is my 1. So if x is 0, if I substitute here, what is the c? X is 0, y is 1. So c will be my pi by 4. Tan of x plus pi by 4. Now when it will be my singularity? When it goes to the infinity. When the tan value will be infinity, and we all know it's a pi over 2 is infinity. So when this value will be pi by 2, when this value will be pi by 2, this value will be pi by 2 only when x will be, if I substitute x is my pi by 4. What is the pi by 4? 3.14 divided by 4, 0.78. Okay, and 0.78 is belongs to this interval. Clear? So that means we can get a x which is my 0.78 or approximately pi by 4, so that this solution becomes my infinity. That means it's a singularity. So once it's a singularity, so the solution becomes a infinite value. So it's a unbounded solution. All options are my correct answer for this particular problem. Okay, this is fine. Now if you think that why I consider the 1, you can take any value in between this closed interval. For example, if I choose, if I clear this screen for you, if I choose x is my 0, then your solution equation becomes y square. So then it becomes my 1 over y is x plus c. If I substitute x0 is my 0, then c becomes my minus 1. So minus 1 over y is x minus 1. So what is the y is here. So clearly say this solution will goes to the infinity at x is equal to 1 and it lies in the closed interval. So that means this solution again has a singularity at x is equal to 1, which is a part of this, and it has an unbounded solution is a part of the, because it's a closed interval. Pi by 4 is also lies in the closed interval. 1 is also lies in this closed interval. So that's why you can choose any value in between them. Okay, look at this another one. Y is a continuously solution of the initial value problem. Y dash plus 2y is fx, where fx is my here. Just like say this is my step function. Then y of 3 by 2. I think it's a very simple. You can solve this equation. How you can solve this equation? Integrating factor is e raised to power 2 dx, e of 2x. So I can get the solution as this, which is integration of integration of fx into e raised to power 2x. Now I can break this fx over this portion. So when it's a 0 to 1, its function is 1, otherwise 0. So what is that? If you integrate them and substitute the upper limit, e raised to power 0 1 over 2. Fine. Now your target is to find the at x is equal to 3 over 2. So it's a e raised to power 3, it's e square minus 1 over 2, and denominator is my e cube. So if I take 1 over e cube, it's a e square minus 1 over 2. Now you can see it's not a sine hyperbolic 1. If I take 1 over e square is here, 1 e I can multiply them, is e minus 1 over 2. What is that? This is 1 over e square sine hyperbolic 1 is my right answer of this problem. Sine hyperbolic 1 divided by e square is the right answer. Okay, look at this one. Which of the following functions are true? Increasing, decreasing, bounded, and here. Now it's a y dash. First of all, when the function will be increasing or decreasing, at which points? How you can check about the increasing or decreasing? We always check the points which is called as critical point. How you can find the critical point? We can take the first derivative to be 0, and it is already given as a derivatives. So what is that? When it will be 0, either y0, either y1 or y2. Fine. Now we can check about the nature. It's a minus infinity, it's a plus infinity. Whenever minus infinity to infinity, take any value, say 0.5. This is my negative, this is my negative, this is my negative. So complete product will be my negative. Take any number between 0 and 1, say 0.5. This number is my positive, this number is my negative, this number is my negative. So the product will be my positive. Take any number between them, say 1.5. If I say 1.5 is a positive, positive, negative. So this number is my negative. 2 to infinity, so say number 3, positive, positive, positive. This number is my positive. Now look at the option. Y of 0 is 0.5. Y of 0 is 0.5. Y of 0 is 0.5. Then y is decreasing. But you can see in this case 0.5 is lies here. Fine, but it's positive means it's a increasing. But he said decreasing. 1.2 lies here. Fine, 1 is a decreasing, but he said increasing. 2.5 lies here. Y is unbounded, that's true, because it's increasing. It's increasing like here, and upper value, and this is my unbounded. So this is a correct option. Y of 0 is negative, so any number here which is a decreasing like of here. Fine, and it's a bounded below. It's a bounded below, but it's a bounded above. This is a bounded. It's a bounded above, but it's a unbounded below. It's unbounded below, it's a bounded above. Because it's a below, this option is cancelled. C is my right answer. Look at this another one. If A is my continuous function, consider the only differential equation infinity, infinity. Okay, fine. what is given to you? Y dash is a into y. Okay, so I can little bit calculation of this, because a is any continuous function which satisfies certain properties. A, so that means if I integrate them, y is, or you can say log of y, a x dx, fine, or y is my c times e of ax dx. Limits are from 0 to infinity, fine, and y0 is my 0, y0 is my y0, so I can find the value of the c, e of ax. So whenever it's a 0 to infinity, so this value becomes my here, fine. So I can see as a y0, so I can simply take, this is my constant, so y is my, say, constant, e of ax dx. Now look at that. If this integration is my finite, fine, if this integration is my finite, then can you say it is a bounded? Okay, so look at that. If this integration is my finite, fine, so then this value becomes my y is y0 e raised to power some finite number, fine. So if this is my finite, then y is my bounded. Can you say it is a bounded? Can you say how you can say it is a bounded? If this limit which are the following is my true, okay, fine. If this is a finite, it means it can never be 0. So it means this is my constant function if it's a finite, because its integration is finite, it is a constant number. This value, if finite, means it's a constant number, fine. So let's say it's a 7, so this number becomes my y0 e raised to power 7, which is always less than of some number. So that means it's a bounded, correct option. Whenever this condition hold, then limit x approaches infinity of y, and since this is independent of x, this is a constant number, so this is also a constant. So what is the meaning of that? Limit existence, fine. Look at the third option. If limit of the ax is my 1, limit of ax is my 1, so then this y is integration of 1 into dx, fine. So this is y0 e raised to power x. Then the limit x approaches infinity of y, what is that? It's a y0 e raised to power infinity, it is my infinity. So this option is also correct option. If limit is my 1, again this option is correct. Then y is a monotonic function. Can you say this function is my monotonic? That means y is equal to y0 e raised to power x. Can you say this is my monotonic function? So look at that, y0 is my non-zero, so e raised to power x is my here. So clearly say e raised to power x is my monotonic function. So this is also monotonic. Either it's a monotonic increasing or decreasing, but it is not mentioned, so it's a monotonic function. All are my correct options. Okay, look at this another one. What is given to you? Consider a function which is here, alpha is my greater than 1. We say the solution exists globally if existence for all t. Now you can see answer is dependent on the alpha, and statement is depending on alpha, but this is not on the alpha. You can choose any of the alpha. Say alpha is my 2, y0 is a greater than 0, I can choose as a 1, z0 is my greater than 0, I can choose as a 1. So first differential equation becomes my y dash is y square, this value is my 1, fine. Now so this is 1 over y square, dy is 1, so if I integrate them, 1 over y is x plus c, fine. So can you find the value of the c from here? C is my minus 1, so therefore minus 1 over y is x minus 1, y is my 1 over 1 minus x, fine. Oh sorry, this is in terms of the t, so I can say y is 1 over, here instead of the 1 is x is in t. Now Does it exist now when it's said to be the global? When it existence for all t greater than 0, does it existence for all? No, it is not exist when t is equal to 1, which is a greater than 0. Fine. So it means this, the solution exists globally if this condition holds. So but this condition does not hold, it means it does not exist globally. So both existence globally cancel out. There exists a global solution for the star, but we already discard this option here. Now look at this second option. dz over dt is my minus z square. So if I take on this, it is my z square, it is my minus dt. Now if I integrate them, minus z minus t, if I constant as a c, so 1 over z is t plus c. So what is that? z0 is my 1. Fine. So what is that? C will be my 0 by using this condition. So 1 over z is my t, or z is my 1 over it. Now clearly say it existence for all t strictly greater than 0. It's a strictly greater than 0. So yes, it means yes, double star global solution exists. Fine. He said none of them has a global solution. This option is also cancelled. So only the left option is my D is the right answer. But how we can see? There exists a global solution of the double star. Yes. And there exists a capital T which is a finite solution of the y. This is my y. Limit small t approaches to the capital T, 1 minus small t is my infinity. This we want to prove them. Okay, what is the capital T? Is a less than 0. Yes, I can choose capital T is my 1. If I choose the capital T 1 which is less than infinite, less than infinity, so it means when I take small t approaches to the 1, then 1 minus t will goes to the plus infinity. So yes, the option D is my correct answer. Although the first three options I already discard by taking the simple counter examples, only left option is the right answer of the problem. Okay, look at this another one. The system of the equation is here. The solution existence only this and this. Okay, now your target is to find the x and y. Fine. Okay, if I divide them, what is the dy over dx? If I divide them, this value will be cancelled out. It's a minus x over y. So what is that? It's a y dx plus x here. What does it mean? X square plus y square is my constant. Fine. So once is a constant, you can substitute this value. So what is the value of the c? C is a square plus b square. So this is my right answer. It existence for any a comma b, that's not true because it exists only for here. How you can say what is the meaning of the t approaches infinity? That means steady state solution. Fine. So once is a steady state solution, this value becomes a 0, this value becomes a 0 at t approaches infinity. So that means although this has only the one correct option, so C is the right answer, but we will see it means this value will be 0 and 1 plus x square of x will be 0. Clearly say this number will not be 0 because it exists on the real line. So it means y will be my 0. This means x will be my 0. So it means x square plus y square will goes to the 0, but he said goes to the infinity. So this option is cancelled. Only if this case, because there in these two cases t approaches infinity is not there, so we can solve like this way. So this will goes to the a square plus b square. So these options are cancelled. C is the right answer. Look at this another one. Okay, which of the following is here? Again t approaches infinity, infinity, infinity and infinity. That means we are talking about the steady state solution. Fine. So what is the steady state? X dot, y dot is fxy. So this value is corresponding to the x dot is equal to this, y dot is equal to this. For the steady state, this value becomes my 0. That means y plus x 1 minus x square minus y square is my 0, and minus x plus y of this case will be my 0. Fine. So if I simply say y is equal to minus x 1 minus x square minus y square, and x is equal to y 1 minus x square minus y square. So if I divide them, our target is to find the x square and y square. So how you can say, if I multiply this by x, this by y, and subtract them, it's a x square, xy, it's xy 0, it's a minus, I can take this value as a common. Fine. It's a minus x square, and I subtract them, it's a minus here. So when it will be 0, so it means either this number will be 0 or 1 minus x square minus y square is 0. Fine. So that means, it means x square plus y square will goes to the 1, or x square plus y square will goes to the 0. Fine. So this is a remain a bounded solution. So can you say it's a bounded? How you can say it's a bounded? This option is correct, but it is not obvious that it's a bounded, because it will goes to the 0. Okay, first option, this is cancelled, this is 0, but this will goes to 0 only when x is 0 or y is 0. So that means it's a equality 0. It's a remain unbounded, because only I am worried about whether it's a remain bounded or not. Whether it's a bounded. Okay, just wait. This x square, first this option is definitely cancelled. Okay, now look at that, x square y square goes to the 0, that's fine. Whenever it either goes to the 0 or 1, it means it's a bounded function, that's correct. X square plus y square will goes to the 1, is it correct or not? Now from here, if you look about that, if x square plus y square goes to the 1, so this means y will goes to the 0, x will goes to the 0. It means it has a boundary, but initial condition is only as a 0.5. It means y will goes to the 0, x will goes to the 0. So this function will not be happens. It's a bounded function, but it will goes only to the 0. So the right option is my B and C are my correct options. Or moreover, if you look about this case in this manner, if I divide them, it will be y over x, it is minus x over y. So when you cancel out, it means x square plus y square will never goes to the 1. Then only you can cancel out. So that means this number will not be possible. So from here again you can see y square plus x square will goes to the 0. So that means this number is only correct option. It's a bounded function, fine, but it will never goes to the 1. So therefore the right options are my B and C are the correct answer. Okay, look at this one. A system is given to be here, and in this case there is no infinite solution. F is my locally ellipsis condition. Okay, so once it's a local ellipsis, it means there is no guarantee about the global solution. Or here x0 is here, at most one solution, always exists a global. The word is always. Once it's a local solution, then what can you say about the global? The global may be or may not be, but he said always, so that option is cancelled out. There might not be any solution, so that's wrong. Why? What is the meaning of the ellipsis condition? That means either locally ellipsis condition, that means either you will get as a unique solution, fine, no, yes, fine. So why you can say it's a no solution? Because you can see one solution is already given to you, initial condition, one solution is already given to you, so there might not be any solution. That's the wrong option. One solution is already given to you. Now he said a locally ellipsis condition. What does it mean? Either it has a unique solution or it has infinitely many solution, because no solution is not possible. So when it will be the unique solution, there is at most one local solution. Fine, at most one local solution, that means unique solution. So that's possible. And there is at least one solution. At least one solution means it has infinitely many solution. So that's the right options are my A and D are the correct option. Remember, this is the word of the local, and I think there is no need of this sign of ex2 and x2 are the function, because we can simply think about the concept of the locally and discard the options. Look at one more function. Function is given to you as here. Related to this ordinary differential equation, we have the following assertions. Solution is blow up and solution is blow undefined. What is the meaning of the blow up? It means if you have a solution which is either the increasing, decreasing or anything, but it is bounded in between the two lines, say y0, y1. That means if you prove that your system, like any of the function df or this is my bounded, what is the meaning of that solution is bounded? It means it is my blow up. Fine. Now we can check about this. So for the first case A, what is my dx over dt? This is x cube. Fine. It is not always less than of something, because what is the range of this? It's a complete R. There is no upper bound we can see from here. It is x minus 0 is less than A, y minus 1 is less than B. But what is the A? A is the part of this real. So we can't find off this one. It means it is my not bounded. So if this is not bounded, it means it is not blow up. Fine. So A, the solution of A is blow up is a false statement. So both are true. One is to cancel. Now look at the B. dy over dt. It is my x sine x square. So this is always be less than or equal to x, because this value is my 1. And what is the mode of x is less than of A. Whatever the value of this we can get as a less than bound. So that means this is my bounded function. Fine. Once is a bounded function, it means it has a blow up because of this sine or cosine function. So it means this is a blow up function is my correct statement. So both are false. Only the right option is my D is the correct answer of this problem. So this is the way you can solve all these initial value problem in a very simple manner. We will see the next lecture on the matrix space. Till then, you can simply scan and join my WhatsApp group for the various discussion. I hope you can share, like and comment on my video. Best of luck, students. Happy learning always.